All right, last few things. So in talking about perpendicular, the one rule is that the shortest segment from a point to a line is perpendicular to the line. So if you look at this triangle here, and this triangle has several segments that are a part of it, okay? And I've taken the liberty and drawn out for you what the longest segment is, another segment that's long but not quite as long. Then you've got a shorter segment, but then you have the shortest one. And notice that the shortest one is perpendicular to the line that we're talking about, and that's really all they mean. So, and another thing that this is, you know that this is the height of a triangle. Okay, that's the there's a word for it. That's your inner height whenever you're figuring out the triangle height of a triangle that way. So, but anyway, so let's get to work on one more very special theorem, and I'm going to write it down real quick. And that theorem is this: perpendicular transversal theorem. In the plane, okay, that's just your two-dimensional flat surface, okay. In the plane, if a transversal is perpendicular to one of two parallel lines, to one of two of them, okay, then it is perpendicular to the other line as well. So if we were to examine our image that we have over here, if you think about it, uh, these ones with the arrows, those are your parallel lines. So that means that this would be one of the transversals that they're talking about, the transversal that is perpendicular to one of two parallel lines. So we know it's perpendicular to this one because here we see the little right angle symbol, but we don't see one here, right? But but not theoretically, but by definition, since these two lines are parallel, line L and line M, since line L and line M are parallel, they have the same slope and the same steepness. So if this makes a 90-degree angle, then this also makes a 90-degree angle. It's also perpendicular. And once again, that is the perpendicular transversal theorem. Even interestingly enough, even if it wasn't, don't you notice that both of these angles are also corresponding angles, right? And so they would have the same, and since these lines are parallel, they would have the same measure anyway. So there's a lot of reasons that this makes sense. Um, but that is your perpendicular transversal theorem in a nutshell. So so let's just very quickly recap what we've learned. Uh, so if we're looking at this image right here, we know the shortest side is this here. This is the shortest. Okay, this is the shortest line segment because it's the one that's perpendicular to this line here. And so if we wanted to, if they gave us directions and they said, hey, write an inequality, sorry, so write an inequality and solve for x. Okay, well, that's really, really not too bad, because we've got x plus 3, but whatever x plus 3 is, we know that this big segment AB over here, or AP, we know that segment AP is greater than segment PB. We know this because PB is the shortest one. So now I'm just going to use the substitution property, and we're going to say, so AP is x plus 3, and that needs to be greater than 5. All right, now we'll just solve it. Subtract 3 from both sides. So whatever value x is, it needs to be a number that's greater than 2. As long as it's greater than 2, then this situation here is true. And that might be a type of problem that they give you, but that's just something that's not too hard to understand. And then finally, let's put a little bit of what we know into practice. So we've got this funky looking image over here, and this might seem a little tricky, but it's really not so bad. So let's think about what we know. We've got two perpendicular uh, sections here. So this here is a transversal cutting through these two lines. And since these are both perpendicular, well, we've got the perpendicular transversal theorem that says that if a transversal is cutting through two parallel lines, then we read it before. if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. So that means, since we've got those perpendiculars there, we can say that these are, whoopsie, I don't want that at all. That means I can say that these here are parallel lines. All right. I need to know that. I need to know that because now I can talk about the angle relationships that we have here. I can say that, let's see, we can say that x plus y and x, those are a linear pair, right? So that means their sum is going to be 180 degrees. I know that, let's see, x and 2y don't have a relationship, but it looks like x, I got two parallel lines, and here's the transversal. This one's on the bottom side, that one's on the top side, so it looks like x plus y and 2y are alternate exterior, because on the outside of the parallel lines, they're alternate exterior angles, which means those are congruent, right? They're going to be exactly the same. So let me start using the information I have and start making some things happen. So I can say that x plus y equals 2y. And you might be like, well, why do I get to say that? Because that is because those are alternate exterior angles. All right. So then I'll just go ahead and solve it. I'll subtract y from both sides. That's just because of the subtraction property of equality. Right? And so I'm going to get x equals, well, 2y minus y is 1y. So that's pretty cool. So now I know that x equals y. Right? So now so now I can say something else. I'm going to say that, let's see, x plus x plus x equals 180 degrees. Now you may be wondering where I got that from. Okay. Well, I remembered that because x plus y and x are a linear pair, their sum is 180 degrees. And so I would normally write x plus y plus x equals 180 degrees. But now I know that x is the same as y. So whereas before I used subtraction property of equality, now I'm going to use the substitution property of equality. All right. And I just plugged in x for y because they're apparently the same thing. So now I'll just continue solving that. X plus x plus x is 3x equals 180 degrees. And so after I divide by 3, x is going to equal 60 degrees. And if x equals 60 degrees, well, x is the same as y, so that means y equals 60 degrees. And there we have solved for both x and y. And we're done for the night. See you guys tomorrow.